7 pi over 6 times 180 over pi. The pi's cancel out. If you take 180 times 7 divided by 6, you get 210, which is the answer. Here's triangle ABC. B is a 90-degree angle, BC is 16, and AC is 20. There's a second triangle that's similar, and the vertices match up like so. The ratio is 1/3, but we're looking for the sine of F, which is the same thing as the sine of C. So the sine of C is the opposite over the hypotenuse, so we need to figure out this value. We know that x squared plus 16 squared is equal to 20 squared. So it looks like x is going to be 12. This is the square root of 144. So opposite over hypotenuse is going to be 12 over 20. I can simplify this by dividing by 4, and it's 3/5. It does not matter the ratio of the side lengths because the angles will be congruent. So if the sine of C is 3/5, then the sine of F is also 3/5. If we want to figure out AB, knowing this length, AC, would help. Then we could use the Pythagorean theorem to figure it out, so that would work. If we knew the measure of angle ABC, then we could use cosine of ABC is equal to adjacent over 25 and figure out it that way. So either one would give you the answer. So on this unit circle, there's a couple of different coordinates that repeat over and over. When you're at 30 degrees, you have root 3 over 2 and 1/2. When you're at 45, you have root 2 over 2 and root 2 over 2. And when you're at 60, you have 1/2 and root 3 over 2. And there's the radian equivalents here, pi over 4, pi over 6, pi over 3, etc. Because we're looking at root 3 over 2, we know that the other coordinate is going to be 1/2. And given where it's at negative 1/2. If the sine of x is a, then the cosine of 90 minus x is also going to be a. Consider this right triangle. Here's an angle x. Sine is going to be opposite over hypotenuse. And then if I consider over here, which is 90 minus x, I'm going to be looking at adjacent over hypotenuse. And they'll be the exact same thing. So that's why the answer is C. Since they tell me sine theta is equal to 2 over 5, opposite over hypotenuse would look like this. But this is not a 5, it's a 10. So we'll make this one a 4 to keep that ratio. Now I can set up, we'll call this AC, the Pythagorean theorem. AC squared plus 4 squared is equal to 10 squared. AC squared plus 16 is equal to 100. AC squared is equal to 84. AC is equal to the square root of 84. So if AC is equal to the square root of n, what is the value of n? And the answer there is 84. So there is a point W somewhere on this line RT. I'm going to say it's right here. And if I'm looking at this angle, which is RSW, the cosine of that would be adjacent over hypotenuse. But we can ignore that for now and just call it the cosine of angle RSW. And this is equal to the sine of 90 minus that angle, RSW. We don't have to know what they are, they're both ratios, but the cosine of the one is equal to the sine of 90 minus the other. If I look on this side, I'm looking for sine of WST. The whole thing used to be 90. So another name for this angle WST is 90 minus RSW. So what you might have noticed is I can call this sine of 90 minus angle RSW, and I can call this sine of 90 minus RSW. So when you subtract it from itself, you're left with 0. ABC and DBE are right triangles, and based on the setup, they are similar. So the cosine of B is equal to the adjacent over the hypotenuse, which is 6 over 10. I could simplify that to 3 over 5. They tell us that the sine of A is equal to the cosine of B. So based on this, we know that A plus B is equal to 90. Because the sine of, let's say, 30 degrees is equal to the cosine of 90 minus 30, let's say 60. That's just one example. So we can plug these in and say 4k minus 22 plus 6k minus 13 is all equal to 90. I can combine like terms, move the 35 over, and k is equal to 12.5. So what are some things I know for sure? BC, the hypotenuse, is 15. So if I consider the tangent of angle B, I could compare either DE and BD, or I could compare AC and BA. Let's do that second one since we already have the hypotenuse. So it's possible that this would be 3 and 4. If I square those, 3 squared plus 4 squared, does that equal 15 squared? And the answer is no. What about if I took 6 squared plus 8 squared? Still no. What about 9 squared plus 12 squared? Well, yes, this one does equal 15 squared. So I just tried different multiples of 3 and 4 until I found one that would work. And that tells me that AC is going to be 9 and BA is going to be 12. They also tell me that DA is 4, meaning that this length is 8. So there's a proportion here. 8 is to 12 as whatever DE is to 9. So it's going to be 2/3. So the answer is going to be 6.